Hey math lovers, Miss Amber here again. So let's talk about the Pythagorean Theorem and some examples of how to actually use it. So this is Pythagoras. He's the guy that actually came up with this theorem, and I'm sure there's some long proof of it somewhere, but we don't need all of that. We just need to know how to use it. So if you recall, the Pythagorean theorem is a squared plus b squared equals c squared. But what does all of that mean? Well, a and b, they're the legs of a right triangle. So they're always going to meet at the right angle. It doesn't matter which leg is A or B. You can switch them as much as you want. But the hypotenuse always has to be C. And it's always going to be the longest side across from the right angle. So let's look at some examples. So take this right triangle here. Say we have two legs that measure 3 and 4 units. So we want to find the hypotenuse. So let's start with the formula. A squared plus b squared equals c squared. So since we know the legs, let's fill in those pieces for A and B. So we'll replace A with 3, we'll replace B with 4. Now remember, the legs are interchangeable, so if you want to put 4 in for A and 3 in for B, that's totally fine as well. So that gives us the equation 3 squared plus 4 squared equals c squared. Now let's solve it. So we square those two values, 3 squared is 9, 4 squared is 16, and that gives us 9 plus 16 equals c squared. We still have to get to c though. So now let's combine our like terms. 9 plus 16, that equals 25. Now we have 25 equals c squared. So what do we do from there? Well, remember that the inverse of squaring something is the square root of it. So in order to solve for c, we have to square root both sides to get c by itself. So when we do that, we find that 5 equals c. And then we see that our hypotenuse is 5 units long. This is actually a Pythag Triple, 3, 4, and 5. That means if you know the legs of your right triangle are 3 and 4, you automatically know the hypotenuse is going to be 5. That also means if you know the hypotenuse is 5 and one of your legs is say 3, then you automatically know the other leg is going to be 4. A Pythag Triple is a set of whole numbers that always make the Pythagorean theorem true, such as 3, 4, and 5. So let's look at another example where now we have to find a leg. So let's take this right triangle. So one of the legs is going to be 5 units, and we see our hypotenuse is 13 units. So remember, the hypotenuse always has to be c. So now when we set up our equation, we're going to have 5 squared plus b squared equals 13 squared. Notice our numbers are on opposite sides of the equal sign this time, so it's going to be a little different. We're still going to start by squaring the values we have. 5 squared is 25. 13 squared is 169. So that gives us the equation 25 plus b squared equals 169. Now maybe you decided to put 5 in for b, so your equation might say a squared plus 25 equals 169, and that's totally fine. You'll get the same answer. So now because our numbers are on opposite sides of the equal sign, we're not going to add them. Now we actually have to subtract them. So we do 169 minus 25, and that leaves us with the equation b squared equals 144. So we're going to do the same thing like we did in the first one and square root both sides so that we can get our variable by itself. So square rooting both sides gives us b equals 12, and we see that the other leg is 12 units. Notice all of those sides are whole numbers, just like 3, 4, and 5, but they're 5, 12, and 13. Remember, a set of whole numbers that makes the Pythagorean theorem true is considered a Pythag Triple. So 2 Pythag Triples we've learned so far are 3, 4, 5, 5, 12, and 13. There's an infinite number of them. There's like 8, 15, 17, 7, 24, 25, 9, 40, 41. You can Google it, you'll see a whole bunch. You can even multiply some of these by another factor. So say for instance I take a 3, 4, 5 triangle and I multiply all of the parts by 2. What am I going to end up with? You got it, 6, 8, 10. That means 6, 8, 10 is another Pythag Triple. So say I take a 3, 4, 5 and I multiply all the parts by 3. Then I'm going to end up with a 9, 12, 15. That means 9, 12, 15 is a Pythag Triple as well. So as you can see, there's a pretty long list of Pythag Triples. But now you know how to use the Pythagorean theorem.